Ever get that feeling like time is just, I don't know, slipping away?
It's a universal experience, isn't it?
Yeah, but it got me thinking. I mean, we all know how to tell time, but what even is it?
Ah, the age-old question.
Exactly. So today we're tackling a real head-scratcher.
Oh, I love a good head-scratcher.
The origin of time itself.
Now we're talking.
We'll be diving into, well, excerpts from The Birth of Time, How and Why It Started. You know, the book you sent over.
A fascinating read.
It really is. And it's going to help us explore some seriously big questions, like how did time even begin? Why does it seem to only move forward? And could it ever reverse or just, vanish?
Questions that have puzzled philosophers and scientists for centuries.
All right, so I'm already feeling a bit lost. Before time. How can there even be a before if time doesn't exist yet?
That's the paradox, isn't it? To grasp this, we need to wrap our heads around the singularity.
The singularity.
Imagine everything, and I mean everything, in the entire universe squeezed into this infinitely small, unbelievably dense point.
Okay, I'm trying to picture that. Everything squished together.
No space, as we understand it, and crucially, no time.
So the laws of physics, they just don't apply.
They break down completely. It's a realm where our everyday understanding of reality just crumbles.
All right, so no time, just this.
Yep.
Singularity. Then how do we get from that to, well, the universe with planets and stars and time ticking away?
That, my friend, is where the Big Bang comes in.
The Big Bang. Okay, but I always get tripped up here. Wasn't the Big Bang just an explosion in space?
That's a common misconception. It wasn't an explosion in space. It was the creation of space itself.
Whoa, hold on.
And along with space, time was born.
So space and time, they're like a package deal.
In a way, yes. Einstein's theory of relativity helps us understand this.
Einstein. Always got to bring in Einstein.
Well, he revolutionized our understanding of, everything. He revealed that space and time, they're not separate entities. They're interwoven.
Interwoven how?
Into a four-dimensional fabric. We call it spacetime.
Spacetime. Okay, trying to wrap my head around that.
Think of it like a cosmic tapestry. And the Big Bang. That's the moment the looms started weaving.
So space-time is created in the Big Bang, and that's when time begins.
Got it.
Precisely.
And here's the kicker. As the universe expands, so does space-time itself. And with it, time.
Okay, so the universe gets bigger, space-time gets bigger, and time, stretches out.
You got it. Our source uses this great analogy. Imagine a balloon.
A balloon, okay.
You've got dots on the surface representing galaxies. As the balloon inflates, those dots move apart, right?
Right, farther apart, like galaxies moving apart as the universe expands.
Exactly. Now, picture the very act of inflating the balloon. That's the creation of both space and time.
Okay, I can see that. But why is the universe expanding? Mean time is expanding. What's the link?
The key is change.
Change.
Time is fundamentally linked to change. Think about it. The Big Bang set everything in motion. Stars forming, galaxies colliding, particles interacting, all this constant change.
Okay, lots of stuff happening.
And time. Time is essentially a way to measure those changes happening in the universe. No change, no time.
So time is like a cosmic heartbeat? Marking the rhythm of a, ever-changing universe.
I like that. A cosmic heartbeat.
But what about the very beginning? I mean, before stars, before galaxies, there was just what?
To understand that, we have to go even deeper, down to the realm of quantum mechanics.
Quantum mechanics. Things are about to get weird, aren't they?
Oh, you have no idea. Think of it like this. A quantum soup.
Quantum soup.
Where particles are popping in and out of existence. It's all about probabilities, not the straightforward cause and effect we're used to.
So how do we get from this bizarre quantum soup to the kind of organized universe we see today? If it's all random, wouldn't it stay chaotic forever?
Well, there's this concept called cosmic inflation. It's thought to have happened a tiny fraction of a second after the Big Bang. Imagine a super fast expansion, faster than the speed of light.
Wait, faster than the speed of light? Isn't that, impossible?
Under normal circumstances, absolutely. But the early universe, that was anything but normal.
So what did this inflation do?
Think of it like smoothing out a crumpled piece of paper. It took all that chaos, all those quantum fluctuations, and stretched them out. That's what created the seeds of the large-scale structure we see in the universe today.
So inflation is like setting the stage for stars and galaxies to form later on.
Exactly. And it's not just about smoothing out space. Inflation kick-started time as we know it. Before inflation, time was, undefined, blurry, maybe even non-existent.
And then, bam, inflation happens.
The universe expands like crazy, and suddenly time starts ticking.
Okay, so inflation brings order and gets time going. But why does time only move forward? Why can't we, rewind like a movie?
That's the million-dollar question, right?
Yeah.
Maybe the answer lies in something called entropy.
Entropy. Vaguely familiar. It's got something to do with disorder, right? My desk has high entropy, but my carefully organized sock drawer, low entropy. Am I on the right track?
You got it. Entropy is basically things getting more disordered over time. So picture this. The universe starts out in a low entropy state, incredibly hot, dense, and uniform. But as it expands and cools down, entropy increases. Things spread out, get more random.
Okay, I'm with you so far.
It's like shuffling a deck of cards. You start with a nice, neat order, but each shuffle, things get a little messier.
So the universe is, just naturally messy, and how does that tie into time?
That increasing entropy is what we experience as time moving forward. Think about it. Entropy is why stars are born, burn their fuel, and then die. It's why your coffee gets cold, why ice melts, and why we age. It's like a driving force. Time's arrow, always pointing from order to disorder.
So if I'm following you, entropy is the reason time can't go backwards. But hold on. If the early universe was so ordered, where did that order even come from?
Now you're getting to the really big questions. That's something physicists are still trying to figure out. Entropy explains why time moves forward, but not its origin. There are some theories out there. Maybe the universe transitioned from a previous state, possibly colliding universes, or even a quantum fluctuation that gave rise to ours with its initial low entropy. But the ultimate source of that order is still a mystery.
Okay, mystery unsolved. But back to entropy for a sec. It gives us that arrow of time, always pointing towards, more mess. But could it ever reverse? I mean, the laws of physics work the same in reverse, don't they? Like, a broken glass could theoretically put itself back together.
You're not wrong. The laws of physics themselves, they don't seem to care about which way time goes. But for time to reverse on a large scale, the entire universe would have to spontaneously become super-duper ordered. It'd be like every single card in that shuffled deck, suddenly arranging itself back into perfect suits in numerical order.
So not impossible,
Yep.
just wildly improbable.
Exactly. The odds are, let's say, astronomically against it. But there's another layer to this whole time thing, something that might make you rethink everything you thought you knew about now.
Okay, hit me. What about now?
Well, remember Einstein and that theory of relativity we talked about?
Einstein's back.
He throws us another curveball. Time, it turns out, isn't universal. It's affected by both gravity and speed.
Wait, are you saying my clock isn't ticking at the same rate as yours?
Not necessarily, but it's possible. Think of it like this. Imagine you could spend some time near a black hole. Super intense gravity, right? Well, time for you would actually slow down compared to someone back here on Earth. You could hang out by the black hole for, say, an hour, come back, and decades would have passed.
Yeah, okay, you're blowing my mind a little. So gravity warps time. What about speed? How does that play into all this?
The faster you move, the slower time flows for you. It's relative to someone who's standing still. And this isn't some science fiction thing. It's something we have to take into account with, get this, GPS systems.
GPS.
Those satellites orbiting Earth, they're moving pretty fast, so their clocks actually tick a tiny bit faster than ours down here. We have to adjust for that, or GPS wouldn't work at all.
Wow, so time isn't this fixed thing. It's all relative.
Exactly. And that brings us to what I think is the most mind-blowing realization about time. There's no universal now.
Hold up. If my now isn't real, what is time even measuring?
It's not that your now is wrong. It's just unique to you, just like it's unique to every point in space-time. There's no single shared present moment for everyone. It's like, imagine looking at a star billions of light years away. You're seeing it as it was billions of years ago, right?
Yeah, because it took that long for the light to reach us.
But from that star's now, we would be the ones in the past. Get it?
So everyone's now is different depending on where they are and how fast they're moving.
Yeah.
It's all relative.
Exactly. The universe, it's not a story unfolding with a single present moment for everyone. It's more like, a giant library. Every possible moment already exists. We're just, experiencing them along our own individual paths through that library.
Okay, I need a minute to process all that. No single now, time is relative, and it all started with the Big Bang. But what if that wasn't the only beginning? What about the multiverse?
Ah, the multiverse. Now we're getting to the really weird stuff. The idea that our universe, it's just one of many, and that takes our exploration of time to a whole other level.
Okay, back again, and phew, my head's still spinning from that whole no universal now thing.
Yeah.
But we left off talking about the multiverse. So how does that change how we think about time's beginning? Or, beginnings?
It really challenges our assumptions about, well, everything. I mean, if there are multiple universes out there, each with its own set of physical laws and maybe even a different experience of time, then the Big Bang might not be the only origin story, right? It
Yeah.
could just be one of countless beginnings happening all the time across this vast multiverse.
So our universe and our time might be normal in some universes, but in others, things could be totally different. Time could go backward or be circular or maybe not even exist at all.
Exactly. And it raises a ton of questions, doesn't it? How do these universes relate to each other? Do they influence each other? Could we ever, I don't know, detect them or even interact with them? It's pretty wild to think about.
Yeah, it's making my brain hurt a little.
Yeah.
But if the multiverse is real, it means time's birth wasn't this one-time event. It's more like a constant process, a cosmic symphony of beginnings and endings we can't even fathom.
It is a beautiful thought, isn't it? It pushes us to expand our definition of what's even possible, what's real. We humans are wired to experience this three-dimensional world and this linear time. But what if reality is so much bigger than that?
It's like we're only seeing the universe through a tiny keyhole, just a tiny glimpse of what's really out there. But even just thinking about this stuff has to change how we see our own reality, don't you think?
I think it has to. It highlights how precious and fragile our own experience of time is. I mean, if time can be different or even non-existent in other universes, then the time we have here takes on a whole new meaning.
Yeah, that's what I've been thinking about. If our universe and our timeline are just one possibility, it makes you really appreciate how unique our own existence is.
Absolutely. And it raises some interesting questions, too. I mean, if there are infinite possibilities, does that make our choices less important? Or our actions?
That's where I get lost, honestly. If our lives are just one tiny blip in this grand scheme of things, does anything we do even matter?
That's something each of us has to answer for ourselves, right? But for me, realizing how vast the multiverse might be, well, it doesn't make me think our lives are less valuable. If anything, it makes me appreciate this reality, with all its ups and downs and everything in between, even more. It's like, imagine finding a rare gem amongst millions of grains of sand. It's not less special because there are other gems out there. It's even more special because it's unique.
I like that. It's about perspective. Knowing there could be infinite possibilities out there,
Yeah.
it makes our reality even more precious. But what about interacting with those possibilities? Our source mentioned detecting or even interacting with other universes. Is that something that could actually happen?
That's a question that a lot of physicists are trying to answer right now. There's research being done on whether we could detect traces of other universes, maybe through gravitational waves or, that cosmic background radiation. And if we could actually interact with other universes, think about what we could learn. Studying different versions of reality, different laws of physics, different kinds of matter and energy. The possibilities are, well, endless.
It would be like having a key to unlock infinite doors of knowledge. Well, I think we've given our listeners a lot to chew on about time today. From its mysterious origins to, well, the mind-bending implications of the multiverse. What a journey.
We've covered a lot of ground, haven't we? From the singularity to the Big Bang into the quantum realm, and even gotten a glimpse of that multiverse.
And I feel like I'm seeing time in a whole new light now.
It is something we take for granted. Time, I mean. But it's so much more complex and amazing than we realize, isn't it? So next time you're going about your day, take a moment to, I don't know, appreciate the miracle of time. How it flows, its connection with space, and how it really affects every single part of our existence.
Keep those questions coming. Keep exploring. Keep searching for a deeper understanding of this crazy universe we call home. And remember, your experience of time, it's yours. Cherish it. Until next time, keep those clocks ticking and those minds open.